All right, hey, honors chemistry. This is the video answer key to question 10, which is accidentally the second number 9 in worksheet number 3. So I want us to think about volume with respect to temperature. Be careful. So it says the diagram below left shows representation of a sample of gas at 100 degrees Celsius. Which of the following best represents the same gas at 75 degrees Celsius? So we have to be careful. We cannot compare degrees Celsius. Why? If I look at that graph of degrees Celsius versus volume, doesn't go through 0. But if I look at the graph of volume versus Kelvin, that does go through 0. This is directly proportional. This volume in degrees Celsius is just linear. There's some equation that's like y equals mx plus b. This is just y equals mx. So there's some kind of other amount that could change for degrees Celsius. So it's hard to compare degrees Celsius. The best thing to do is to compare Kelvin. So 100 degrees Celsius is 373 Kelvin, and 75 degrees Celsius, if you add 273, is 348 Kelvin. So now we have to see how has my before changed to my after. So let's see what my change is. My change will be 348 over 373. After divided by before tells me how much has changed. So 348 divided by 373. If I'm doing this, this is telling me how much bigger my after is compared to my before. So I get it's about 0.93 times bigger, which means it's actually smaller. It's smaller by about 93%. So it only, volume went down by 7% of its original. So for example, if I started with 1 milliliter, I'd be going down to about 0.7 milliliters. That would be an example of a change of 0.93. So 348 over 373, that's only a decrease by a factor of 0.93. Which of these has a decrease of a factor of about 0.93? Well, let's eliminate some things. D, this goes down by about 90%. So down by 90%, right? So this would be if I went from 1 milliliter to 0.1 milliliter. Can't be D. C looks like it went down by more, about more than 50%. That means this factor would have to be about 0.5. This factor is not 0.5, so it can't be C. We're stuck between A and B. B looks like it went down somewhere between 40, maybe to 50%. Again, that'd be 0.4 or 0.5. This is only 0.93. Can't be B. Correct answer has got to be A. And then it says if the sample of gas in the box at left was at 373 Kelvin, which would represent the gas at 348 Kelvin? A. Same answer. So be careful. Cannot compare degrees Celsius. Only can compare Kelvin. And if you don't know how to compare before and after, you could just do value after divided by value before, and this number tells you, this number value n is how much bigger or smaller. So for example, if I went from 300 Kelvin to 150 Kelvin, I'd put after over before, that's 2. Sorry, 0.5. Not 2, I mean, it went down by a factor of 2. 0.5 times larger, which is actually 2 times smaller. Right, so going from 300 Kelvin to 150, my temperature decreased by half, which means my volume will also decrease by half. So if I had 1 milliliter, it would go to 0.5 milliliters, same factor. So this is how you look at volume changes with respect to temperature. Do not use degrees Celsius, you need to use Kelvin.